Hello guys, welcome back to Maison African Motives, still on mathematics and working on derivatives, let's just say calculus, because here we've got derivatives. We also have the part of integration. So it's actually a mix that we are going to be working with so that we see how is it about the derivatives and how is it about integration at the same time. So this is November 2020 question paper that you're going to be focusing with, where we are given the first part, f of x is equivalent to x cubed minus x squared minus x. Calculate by using differentiation the coordinates of the turning points and the point of inflection of the given cubic function. Also distinguish between the maximum and minimum turning points by the use of the second derivative. All right, so we have a lot of things that we are given here. To use differentiation, to calculate by using differentiation the coordinates of the turning points. So here we need the turning points. Also the point of inflection of the given cubic function. Also to distinguish between the maximum and the minimum turning points by the use of the second derivative. All right. So let's see how we can attempt this typical question with 9 marks. Is actually they give it like that. All right. So that's question 1.1. All right, so we on 1.1, remember we are given our f of x as x cubed minus x squared minus 2x. All right, so this is our normal function that we are given before. So we are going to start by the turning points in this case. So in order for you to determine the turning points of any function, whether it's a cubic function, it's a quadratic function, it's all about the first derivative that you're going to have that must be equal to 0 at any turning point. That means our first derivative must be equal to 0. So since it is a cubic function, as we can see here, we are going to have a condition where there are 2 turning points. So as you are calculating, you must know that you are expecting to have 2 turning points on this part. All right, so let us have our first derivative with respect to x. So the first derivative with respect to x is going to give us, remember we multiply here, that's 3 times 1, which is 3x, subtract 1, that is going to be x squared, minus 2 times 1, here we subtract 1, so it's 2 times 1, which is going to be 2x, we subtract 1, this is going to remain 2x, minus 2x, that is negative 2. All right. So this is our f prime x, or the first derivative with respect to x, and we are saying we must have this equal to 0 at any turning point. So at any turning point, 3x squared minus 2x minus 2x, which is our first derivative, must be equal to 0 so that we can solve for x. So depending with there are factors or not, if there are no factors, then you are supposed to solve for x from your quadratic formula. In this case, we do not have factors. We've multiplied, this is going to be negative 6x squared. We do not have factors of negative 6x. When we add, we obtain negative 2. So meaning to say we are going to solve this by the use of the quadratic formula. Remember that x is equivalent to minus b plus or minus the square root of b squared minus 4ac everything over 2a, where we can substitute our values. Here we've got our a, our b, and our c. So x is equal to minus b, which is a 2 here, so that's negative 2, which is going to be a plus 2. So here we are going to have plus 2 plus or minus the square root of b squared, our b, that is negative 2 squared, minus 4ac, so that's minus 4 times a, which is 3, so it's going to be minus 4 times 3 times c. Our c is the constant here, which is negative 2. So everything from this part is going to be divided by 2 times a, of which our a is 3. All right, so we can be able to simplify this separately, or you can just maybe simplify the first part, but this is just going to give us something like 2 plus or minus the square root of 28 over 6. All right, if we just simplify this part under the square root, and also to note a minus, and a minus is a plus. So everything is going to be 2 by 3, which is 6. Okay, so this can give us the values of x. So from here, if you are to find from the plus, our x is going to be 1, 2, 1, 5 to 3 decimal places, or x is going to be from this negative, we are going to obtain negative 0.549 to 3 decimal places. Okay, so these are the values of x that you are obtaining from solving. So remember, we are talking about the turning points, meaning to say for 2 turning points. So we shall refer to this as our x1 and this as our x2, like the first point, second point. All right, so meaning to say we can be able to determine the first turning point by substituting these values into the original equation. We can have the first turning point where x is equal to 1,215 like this, followed by the value of y. Remember, a point is given by x and y. So this is going to be x1, y1. From the first turning point, from the first point where x is 1, we substitute into the original equation 1,215. So we're going to substitute 1,215 into the original equation. In place of x, we substitute 1,215. In place of x, we substitute 1,215. And this is going to give us the value of y, which is going to be negative 2,113. So we are going to have our first turning point and our second turning point where x is equal to minus 0.549. So the same thing, we substitute this into the original equation. Take note, our original equation here, we substitute the value of x, which is negative 0.549. Y is going to give us 0.631. So we have a point that is from the value of x, we obtain the value of y. So that's a point. So these are the turning points, the first turning point and the second turning point. But we are supposed to distinguish now between these turning points. Take note from the question here. We are supposed to distinguish them. Yes, we are going to move on to this part to calculate the point of inflection. But here, we are also supposed to distinguish between these to say which one is the maximum and which one is the minimum turning point. All right, by the use of the second derivative. How do you apply the second derivative to determine the turning points? All right, so this is what you're going to have. From your first derivative, what you need to understand is that from the second derivative, let's say we determined our second derivative, which is f prime 2 like this. This is our second derivative. Or maybe it was from dy dx, it's now like this. This is our second derivative. If our second derivative is a value that is greater than 0, which is a positive value in this case, it means the point that we have taken, this is a minimum turning point. So thus there we are going to obtain a minimum turning point. On a condition that our second derivative with respect to x is less than 0, we are talking about values which are negative. If you obtain a negative answer, it means you are having a maximum turning point from there. Take note, negative, a maximum, positive, minimum. So we are going to determine using this idea. So let us find the second derivative first. Where are we going to have our second derivative? From the first derivative. Remember, here we obtained our first derivative as 3x squared minus 2x minus 2. This is our first derivative. So we are going to take our first derivative, then we determine the second derivative from there. All right. So I just hope we saw this, our first derivative. So in this case, remember our first derivative was given as 3x squared minus 2x minus 2. This is our first derivative. Then we determine the second derivative with respect to x. So that's here we are going to obtain 6x negative 2. This is a constant, so that's a 0. So just make sure that you watch also the videos on the derivatives, how to find the derivative basically. Okay, so here we're going to multiply 2 and 3, then we subtract 1. Here it's like there's a 1, so if you multiply, it's going to be negative 2. If we subtract 1, that's a 0. X to the exponent of 0, it's a 1, so it's going to be a negative 2. So this is your second derivative. But we are saying, if we are to substitute these values, so let's start with the first point from the first turning point, this one. From the first turning point that we are given, our x there is 1,215. This is the value of x at the turning point. So if we are to substitute that value of x here, we are going to check what are we going to have. So we are going to substitute that. So it's going to be 6 into x. Our x here is 1,215 minus 2. All right. So if we are to substitute this, that is the value of x that we are having in this case. All right. So this is going to give us something like 5,29, 5,294 like that. So this value that we are having is the one that we are comparing with our second derivative. Are we having a positive answer or are we having a negative answer from there? So in this case, 5,24. 5,294, it's a positive. It's greater than 0. It's a positive. This one is a positive. So if it is a positive, it means that point that we have taken the value of x from, which is our x1, that's our first turning point. It means it's a minimum turning point. For any positive that you get from the second derivative, it means that's a minimum turning point. So it means here, our first turning point is a minimum turning point. So this point here, that's our minimum turning point. The same thing we can prove, but definitely we can't have two minimum turning points from the same cubic function. If one is minimum, another one is maximum. But we can prove that also, say, is this a maximum turning point? Remember what you're going to do. You substitute the value of x into our second derivative. This is our second derivative here. So we are going to substitute the value of x at the second turning point. So this is 6 times our x for the second turning point. This is our x here, which is negative 0,549 minus 2. We still have a negative 2. So if we simplify this, we are going to obtain a negative 5,294. So this is a negative, meaning we are on this side. The second derivative is giving us a negative. It means where we have taken this point, it's a maximum turning point. So that means this point is a maximum turning point. So that's how you differentiate points to say it's a maximum turning point or it's a minimum turning point. You use the second derivative, substitute the values of x that you are given. Is the answer a positive or is the answer a negative? If it is a positive, that's a minimum turning point. Negative, it's a maximum turning point. All right. So that's how we can have this typical question of typical question that you're given. Okay, but don't forget that we still have a condition here on the point of inflection on our question. This was on turning points and determining the nature of turning points, but also we are given here to find the point of inflection here, the point of inflection. All right. So how do we determine the point of inflection? Okay, so this is what we have for the point of inflection. Let me have where we have our second derivative here. So for the point of inflection, this is what we are supposed to note. The point of inflection, it's at a condition where the second derivative is exactly equal to 0. Not greater than 0, not less than 0, but where it is exactly equal to 0, that's at the point of inflection. So what is going to be our point? So in this case, we have got our second derivative. Already we determined our second derivative. That's 6x minus 2. So we are simply going to equate our second derivative to 0. Then we can have the value of x there. So 6x is equal to negative 2 to this side, that's a positive. So we can divide by 6 both sides, thus having the value of x, which is going to be 1/6. All right, so we have the value of x in this case, which is going to give us 1/6. So with the value of 1/6 that we got, to have the point now, we are going to substitute this x, which is 1/6, to have the value of I. So we've got x, we need the value of y. Where do we substitute this x into? Into the original equation that we were given before our original f of x. Remember, before our f of x was given as x cubed minus x squared. So it was x squared minus 2x. So you substitute 1/6 in x, 1/6 in x, 1/6 in x, so that you obtain the exact value of y from there. All right, so this is what you're going to obtain. That's negative 77. All right, so let me have this negative 77 over 216 over 216 like this. All right, so this gives us the point of inflection in this case. All right, so that's how we can attempt typical questions like, so these are applications of derivatives. Here we are working with applications of derivatives when you are given something like this. Okay, so sometimes you can be even asked to sketch the graph that you'll be given from these points. So you must also able to sketch using the information. All right, so that was the first part, having 9 marks. As you can see, guys, a lot of marks that we have. Okay, let's move on to 1.2. This is now on integration. So on 1.2, we are now given to draw the graph of y is equal to x squared minus 4. Clearly indicate the enclosed area and the x-axis. Also show the representative strip used to calculate the area for that. That is 1.21. All right, so on 1.21, we are given in this case to sketch the graph or the curve of y is equal to x squared minus 4. All right. So if you are to sketch graphs, guys, you are supposed to know at least how to sketch each and every function. It's a quadratic function where here the coefficient of x squared is a 1. So if you are not having it in the form of, remember, it's supposed to be ax squared plus bx plus c. If you do not have this plus bx here, your graph is going to be at the point C. Your graph is going to cross at the point C, which is at point -4. So our graph, remember, here it's a positive, so it must be a smiley shape. It's a positive. So here we are going to have our graph, but it is going to pass through -4, which is our y-intercept. Remember, the y-intercept is at x is equal to 0. So if x is equal to 0, y is -4. So -4 is maybe somewhere here. All right. Then we need to know where this graph is going to cross the x-axis. Remember, it's a shape like this, so it's going to pass through the x-axis at 2 points. So where do we find these values of x? We can simply equate this because we know that y is equal to 0 in the x-axis. So if y is equal to 0, it means 0 is equal to x squared minus 4. So that's here. 4 is equal to x squared. So to find x, going to have the square root. So x is going to be the square root of 4, which is plus or minus 2. So x can be a plus 2 or x can be a minus 2. So that is what we are given in this case. So our graph, like I said, the shape is going to be like this. So the turning point is not important when you are to sketch this part. These points are enough. All right. So our graph is going to be something. Okay. So in this case, this is going to be our turning point actually. All right. Okay, I removed another part that I wanted. Okay, no problem. I'm going to indicate it later on. So just save your curve properly drawn. Okay, so your curve is going to be like this. All right, so that is our y is equal to x squared minus 4. Remember, it passes through 2, and here it passes through -2 in the y-intercept at -4, and this becomes our y-intercept for a curve of this nature. If this bx is not there, that's how you simply have it. Yes, you can have another way that you can apply to sketch the curve and so forth. But remember, here we are also told to represent the strip that we are going to use when we are to calculate the area. So the representative strip is between the curve and the x-axis. Take note here. We are told that the representative strip is what you're supposed to have. The area is enclosed area between the graph and the x-axis. So it's enclosed, that is covered by the graph and the x-axis. So the part that is closed by the graph and the x-axis is this part. So this is where we are going to have our area from x, which is -2, up to x, which is a +2. So this is the region that you're going to use to calculate your area. Okay, so that's how we can have, and we can even present this as dx, that is a strip with respect to with respect to x. Then we just write dx, okay? That is with respect to x. Then they are now asking us on the other part of the question, which is 1.22, now to calculate the value of the enclosed area, that area that we talked about. Now they're asking us to calculate it, that is 1.21, by making use of integration. So take note, integration is used, its applications to calculate area, okay? Derivatives, it's all about the gradient and sketching, finding turning points and the point of inflection. Those are for derivatives, but area, that is integration. So sometimes they might not ask you direct to say by using integration. You must know that for area, you use integration. Okay, so this is what we are going to have. So remember, we said area is for integration, but how do we apply our integration to determine the area? Okay, this follows that 1.22, it follows that the area that we are going to obtain with respect to x, here we are talking about the area with respect to x, it is the integral of the function that we are given of f of x. So this is the integral of the function of f of x with respect to x, like this, with the limits a and b, the lower limit and upper limit. So our f of x is this part, which represents y. So you find this formula in your formula sheet written as the area with respect to x is the integral of y with respect to x, like this. They are saying this y is f of x. That's what they're trying to say. So y is simply this part of f of x, which is x squared minus 4. And a and b, these are the limits, the lower limit and the upper limit. So our lower limit is -2 in the x-axis and the upper limit is 2. You take the limits in the x-axis. All right, so meaning to say our area in this case can be determined. So our area, okay, let me use this one back. So our area can be determined because we said is the integral of y, where y is a function with respect to x. That's x squared minus 4. So this is going to be x squared minus 4 with respect to x. And the limits a and b, the lower limit, we said it's -2 in the x-axis, upper limit is +2. So that's -2, +2. So you are back to your normal integration. This is the normal integration that you're having, where you are given limits. So you have to integrate, then you substitute the limits. So remember that the integral now is opposite of derivative. If you are given x to the exponent of n, then this one is going to be to the exponent of n plus 1 over n plus 1 when you integrate. So this is the integral of with respect to x. So this you're going to add, divide by n plus 1. So meaning to say this time we are adding from this part. So our area with respect to x, this x squared is going to be x plus 2 plus 1 over 2 plus 1. So 2 plus 1, that is 3. So it's going to be x to the exponent of 3 over 3. So that's what I'm trying to say. You add 1, then you divide by that same x, the new exponent, which is 3. So you divide by the new exponent on your answer. So this is going to be x to the exponent of 3 over 3. Where there is a constant, you are going to put x. So this is going to be minus 4x, all right? That's our limits to be applied now. We have got 2 and -2. So this is going to give us the area from that region that we are given. But I want you to take note, the region that we are given here, it's below the x-axis. If your region is above the x-axis like this, if we're given something like this, this is the region that you're talking about. This, when you calculate, your answer is going to be positive. But if you calculate this area, your answer is going to be negative. But we must know that area is always the magnitude, that is the positive answer that you're going to have. So you take the positive answer from there. All right, so this is what you're supposed to take note from this. Before you even find your answers, you must expect that to happen. All right, so our area x is going to be, we can substitute our x here. We've got 2, so that's 2 to the exponent of 3 over 3 minus, this is 4 times 2. That's the upper limit, which is a 2. The lower limit is a -2. So we subtract by substituting the lower limit in place of x. So this is going to be -2 to the exponent of 3 over 3 minus 4 into -2 like this. All right. So what you're going to do is to simplify this first part, you obtain your answer. You simplify the second part, you obtain your answer. So this is going to be -16 over 3 minus, here we are also going to obtain 16 over 3. So like I said, this is going to give us a negative answer. So here we are going to obtain our area as -32 over 3 square units. But take note, area is always a positive. So therefore, our area is going to be 32 over 3 square units. So area is measured in square units, or you can just write this as u squared for area. So you take the positive answer. The negative is just because of the region, to say it's below the x-axis. If it is above the x-axis like this one, your answer is automatically a positive. But below, your answer is negative, but you use the positive on your final answer. So with this idea, guys, you can be able to determine any particular area that you're given. All right, so let's check the other part of the question, which is, all right, so we calculate this now 1.3. This is the same presentation like what we had previously, but this one is not on area. It's not on area. It's on work done, but it uses the same concept, just like a question which asks you to calculate area. So remember that work done is from that first times distance concept, but here they want us to use the integral. So they are saying the work done on a particular object is represented by the formula. They've told us that the work done is going to be taken from this formula. P is equal to the integral of 5 over x plus 2 dx. So now they are saying determine P. P is this part, which is the work done. So what are we simply doing? We are simply integrating this part. All right, so P is simply the integral of 5 over x plus 2 with respect to x, in this case, from 1 up to 3. So remember that the integral of 1 over x, if you are integrating 1 over x, it gives us ln x plus the constant of integration. So here it's 5 over x. So this 5 is just going to multiply just like k over x. If it is k over x like this, it's going to be k ln x. All right. So it's the same thing with 5. So here we are going to have p is equal to 5 ln x. All right. We integrate to, remember what I said, a constant. If you're integrating a constant with respect to x, it is going to be ax plus the constant of integration. So you multiply with x whenever you're given a constant, that's ax. So 2 is going to be 2x, all right? Then you have your limits. Don't forget the limits from 1 up to 3. So we've got 1 up to 3. So what does this part mean? Just like what we did on area, on the area part, you substitute the upper limit, which is our 3, the lower limit, which is a 2. When there are limits like this, you see, I'm not focusing with the constant because we are given limits. If you have limits, there is no need for us even to indicate the C. You just integrate direct, okay? So your P is going to be 5. Ln of our x at that moment is the upper limit, which is 3. So x is going to be 3. So that's ln 3 plus 2 times 3, which is 6. Or you can just write 2 times 3. So this is from the upper limit minus the lower limit when our x at this moment, it's a 1. So in place of x, you're substituting a 1 wherever there's x. So this is going to be 5 ln of 1 plus 2 times 1. So this is going to be 2 times 1, which is just 2, okay? So this is just 2 here. So you combine everything from the first part. You can just combine everything with your calculator. So this is going to give us a final answer of 9, so this is going to be 9,493. Okay, so this is the work done that we are given in this case, which is presented by the formula P, where P is given as, and we know that our work done is measured in joules, so you can even write this in joules, since work done is measured in joules, because they say the P represents the work done. So we are mathematically calculating that work done, which we could have calculated by using the formula from your science there. But now we are using mathematical calculations to determine the same thing. So these are the typical questions that you might be given on differentiation and integration. So now the only difference that we have typically is that now we are having our questions separated: differentiation on each part, integration on each part. But this is best for your revision so that you know the difference between integration and differentiation at the same time. For now, that's what we had, guys, for Maison African motives. Till we meet again.